Alright everybody, in this video we are going to find out how to do electron configuration. So this is going to be a bit of a shakier video because I have to move the camera around a bit, but if you look at slide 70 on the slideshow for chapter 6, you'll see a little bit more of a helpful representation. But S is the first two columns, P is the last columns, and D is the ones that are in between, and F is the ones that are below. So let's put this to the real periodic table. These are the S, these are the P, and the ones in the middle are the D. The ones down here are the F. Okay, so we've broken down the table, the periodic table, into S, P, D, and F. Now, if you also look at the slide that I uploaded called Quantum Slides, it's under Documents, you'll also see another image that shows this. So, not only do we have to understand what block we're on, S, P, D, or F, we also have to understand what row we're on. Row 1, 2, 3, 4, 5, 6, etc. So that is lowercase number n. Lowercase number n is what row you're on. Now, for this problem, we're going to find the electron configuration for nitrogen. So, your job is to locate nitrogen on the periodic table. And then it's sort of like reading a book. You kind of go left to right while reading a book. So this is in the 1s block, correct? First row, S block. So this is 1s1. You kind of pretend that the helium here is in 1s2. So 1s1, 1s2 is filled. There is nothing else in the first row, is there? So, if I were to be writing this, and I had my marker somewhere where I knew where it was, I would write that it is, and I found it, that N is 1s2, right? So for nitrogen, if we were to reach nitrogen, if this was our final destination, we would have to fill 1s1, 1s2, correct? Okay. So what's next? We're reading it like a book. So you go from one line to the next line to the next line. So then we're here. This is the second row, and it is also the S block. So we're going to have to fill 2s1, 2s2. And that is the end of that S block, isn't it? So, I'm sorry, I'm new at all of this. We're going to have to fill 2s2 as well. So if we are at 2s2, where are we at on the periodic table? We are at beryllium. Now, if this is our final destination, nitrogen, we're going to have to go in the, what is this lettered block? It is the P block. And what row is it in? This is the first row, so this is the second row, correct? So it is in 2s1, 2p, 2p3, right? So there are how many in the 2p block? 1, 2, 3. 3 in the 2p block. So 2p3. All right. So that's all that there is in the nitrogen. So again, don't panic. Practice makes perfect. So let's do calcium. So in this situation, calcium is here, and that is our end goal. So it's just like reading a book from left to right. Hydrogen, helium, right? 1s1, 1s2. Okay, what else? That's the end of that line. So in the second line, 2s1, 2s2, so 2s2. So I'm going to write those things down. 1s2, 2s2. So where are we at? We're only here at beryllium, right? We're trying to get to calcium. So then we move over here. This is the P block. So 2p, 1, 2, 3, 4, 5, 6, 2p6. So we're going to have to fill up 2p6. Okay. So if we're at 2p6, where are we? We're here. All right. This is 3s1, 2. So we're going to have to fill up 3s2. Okay. Now we're here. This is 3p. 1, 2, 3, 4, 5, 6. This is 3p6, right? Ooh, handwriting. Okay. So 3p6 brings us here to argon. Are we at calcium yet? Not just yet. So let's boogie on this way. And here we are at row 1, 2, 3, 4. We're at row 4. 4 in block S. We need 1 and 2. 4s2. Oh, I can write, I swear. Okay, 4s2. So that is the electron configuration of calcium. So let's do manganese real quick, Mn. So it's going to be very much the same as what we've done before. 1s1, 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. So let's bring it there. Let's put that there. So we are at 1s2, 2s2, 2p6. So that brings us right here to neon. Okay. Then we're at 3s1, 3s2. So we're at 3s2. 3p, 1, 2, 3, 4, 5, 6, 3p6, so that's 3s2, 3, ooh, handwriting, 3p6, there we go. So that brings us here to argon, right? Okay. Now, 4s1, s2, 4s2. And we are now the same as calcium, right? But manganese goes a little further, doesn't it? Now, if you recall, this is the s orbital. These are s orbitals. These are p orbitals. The ones in the middle, these are d orbitals. They kind of look like a bridge, right? Now, the thing about the d orbitals is they start at 3D. So you could think of it as you are in 3D. So it looks like scandium is in the 4th row, doesn't it? The 4th energy level. But in reality, 1, 2, 3, 4, it looks like scandium's in the 4th energy level. But in reality, it's in the 3rd d orbital. So this is 4s1, 4s2. This is 3d. And then this is 4p. So 3d, or the d block actually starts in the 3rd energy level. So we have 4s1, 4s2. And then for manganese, we have 3d, 1, 2, 3, 4, 5, 3d5. If I could write this and then show you. 3d5. Okay? So, if you recall, and if you look at that periodic table that I put on the handout for quantum numbers, you'll see it a little bit more clearly. But the S block starts in the first row. The P block starts in the second row, right? This is 2P. The D block starts in the third row. And then the F block starts in the fourth row. So 1, 2, 3, 4, right? So it all kind of makes sense in the end. So I hope that helps. And let me know if you have any questions.